So yeah, actually, welcome everyone to this webinar, How to Break Apps with Kubernetes. It's a we had great fun picking that title. We actually thought about all the things that you need to watch out for, but really understand how you can make things, not break, because it's very easy to break things with Kubernetes and apps, especially apps, if they're monolithic and so on and so forth. So I'm very happy to welcome Ben here. Who actually has like tons of experience, has been in this industry for a very, very long time. And is working with a number of customers here at Giant Swarm. And great to have you here. So we actually have got a couple of people joining still. Little poll that I actually would like to start, which is, how many clusters do you run? Just to give you an idea. If you actually are running 0, then go for the first option, which is 1, 2, 3. Unfortunately, I forgot that one. You actually should be seeing a poll, and you can answer the poll. Would just be great to get an overview of are we talking to more people that actually basically are at the beginning of the journey, or are we talking to people that actually run and are thinking about how to develop this further? But I can clearly see that we actually have mostly people that are starting off on their journey and maybe running, let's say a single-digit number of clusters for their project. And and that's where it actually becomes very relevant to understand, you can get Kubernetes up and running very easily. Then you deploy your applications, and then the question is what's next? And that's exactly where Ben can, at least give you a lot of insight into what we have seen, what he has seen through all the years. Make this session as interactive as possible. I really welcome you using the chat window. So if you actually then switch back to chat, then you can see at the chat, you can ask questions anytime. I'll actually either pick them up during the presentation or at the end. Please actually ask questions or give comments or share your own experience and ideas. And we actually want to make this very interactive. But for the time being, I actually want to hand over to Ben. Looking forward to a great session again today. Many thanks for coming.
Yeah, thanks everyone. Super excited to talk with you all today, and like Fran said, share some of our hard-won experiences over the years, different customers, different scenarios, and I'm sure you guys can certainly tell us some of your own throughout. So like Fran said, my name is Ben Rain. Currently, I work as an account engineer for Giant Swarm. Career background, I've been doing cloud for definitely a few years now. I started kind of in that game at Cisco as a firewall engineer, actually. So worked in the application layer mostly for that few years. That I went ahead and went to Docker from there. I was a support engineer for Docker for a number of years. And then once Mirantis bought them out, worked at Mirantis for a little bit as well. So definitely, I've seen some different applications, different uses of them, different experiences of them. I'm definitely excited to kind of talk you through both, let's say, the guideline part of it, as well as how would we totally break something in production, maybe if we didn't follow it or we had an oversight. But we'll see more as we get into it here. So for our agenda today, the first thing that we'll do is we'll just do a quick kind of thought exercise considering more than code. After that, we're going to do a going to work warm up, kind of a fun little thought exercise outside of Kubernetes, just to get us thinking in the right context. Then we'll move on, I would say, to kind of the meat of it, where we'll talk about 12-step methodology and then just some real world examples that we've seen of when that hasn't worked out so much. Then we'll go into our pitfall scenarios. And so again, just some real life scenarios of things that we've encountered in customer environments and basically why this was detrimental or why it was hard to get out of, and then how we would actually fix that in a best case scenario. And then finally, just a few short slides on testing tips, essentially just kind of our view on how we make sure that these, by the time they get into production, are the places that we want, reliable, and we're confident in their performance. So First things first, considering more than code. Before we get into how to break things, before we get into, let's say, anything technical, the one thing that we always want to think about Kubernetes is, why are we trying to utilize Kubernetes? So why are we putting the design or the application onto the Kubernetes platform? What are we actually trying to take advantage of? Is it something that we're trying to save cost? Are we looking to really take advantage of the scaling and the performance benefits of Kubernetes? Um, or maybe simply, and this is a totally valid answer, uh, my boss told me to do it, right? And that's one as well, of just, hey, we want you to wrap this monolith and get it pushed, and you're looking for a little guidance on that. All very valid, but long story short, the takeaway from this is, when designing applications, whether they're existing, whether you're decoupling them to put in Kubernetes, or whether you're just building it from scratch, always have that goal in mind of, how am I going to take advantage of Kubernetes and what it offers with this application? So some of the most important ones that we put together of why we would care about Kubernetes and the specific advantages of it. The first one, for I'm sure a number of us who are in the code a lot on a day-to-day, is development speed. So basically just more time for innovation itself. Most of us on this call have probably changed one line in a piece of code before, wanted to test it really fast, did our one change that took 30 seconds, and then had to sit there 20 minutes, right, to wait for the build process just to see that it didn't work, change it one more time, and start the whole process over again. So if we design the tooling around our application, if we design our application to be able to be deployed quickly, we get the more and faster developments from the business agility, the development speed, but ultimately for us in the development world too, less sitting around, more actually doing the fun stuff. Faster time to market. Obviously, if we're able to iterate more, we're able to get more of the actual product value in hand. That's really what we're looking for in Kubernetes, right? We're trying to ultimately get to that point where we can deploy things faster, we can create things faster, we can even fix things faster, right? It's all going to be that value add and exponential platform to come together. And then at the bottom, I would say we have the two most common, let's say, or I should even say most important in my personal opinion. The first one is scalability. All of us being in microservices, we know the value of microservices, how we can scale out vertically, how we can scale out horizontally. But specifically, I think the portability of Kubernetes is something that we have to consider as well, right? When designing these apps, do we want to build it for lock-in? Do we want to build it totally agnostic, third party, from any services, right? So that's always a consideration. And then the last thing, just being improved resiliency. Short story, right? There's no need just to put something up on Kubernetes in a single replica that doesn't have controllers or anything happening. If you might as well run it on a server, right? You're just kind of adding complexity to Kubernetes. So really having in mind, I want to scale up. I want this to be reconciliation. I want this to be immutable code, and essentially just have that resiliency at all time on your application. So now we're going to shift gears just a little bit. Now that we're thinking about our goals and thinking about the big picture of our development, or of our, let's say, pod lifecycle, our application lifecycle, let's kind of switch gears and think about something outside of Kubernetes, and then we'll relate it back. So we'll just do a quick warm-up exercise here. So we'll say we have to go to work, right? So we have to go to work. We have to go to work to get our code done, to maybe submit our buddy's PR review that he's been waiting for us to do. But we have to go to work, and all we need at work is our laptop. That's the only thing that we need to bring to be successful. So we have to go to the building, we have to bring our laptop, and that's all we need to be able to work. So you guys are really, really excited about going to work this day. You wake up early, you pour some coffee, you put your laptop that we need, right? You put that in your backpack, and then you hop on the bus and you try to leave to the office. When you open the bus door, though, you see this nice gentleman in the orange sunglasses staring at you, kind of laughing, kind of smiling, and you suddenly realize that you left in such a rush that you forgot to put on pants. So you're looking around, you're embarrassed, no pants, I have everything ready to go, but I forgot this fundamental thing that I need, completely oversaw it. So to get to the office, we have to be wearing pants. So because we have our laptop, because we have everything else ready to go, It doesn't matter at this point because we can't get into the office. So how can we relate this back to a Kubernetes application scenario? So let's say we've created a perfectly optimized Kubernetes deployment, which is our laptop. It's the only thing that we think that we need to be successful, to be productive. So our pod's running, our code is super optimized, it scales really well, it's awesome. So we have our laptop. We've built supporting tooling around the application. So that being our autoscalers, our resilient, our controllers, right? Things that are gonna monitor the health, restart it if it fails, and then scale it based on need. We've iterated and we've created our build pipeline. Our build pipeline is awesome. We did the best build pipeline that anyone's ever seen, right? And that relating to our bus system, we have a way to get to work. However, we had a single point of failure in the app, and now we can't deploy. So the long story is that because we didn't put on these pants, even though we had everything else ready to go to create this perfect, productive day at work, we forgot the one fundamental thing we needed to get on our transport system, and therefore we can't even get in the building to work. The same is true in Kubernetes. We can design the perfect pod, we can put all the support around it, but let's say that we're using a public image pool and a public registry, and let's say that registry is down that day. If we can't pull that image and we don't have a way to push it into our cluster, any kind of job, any kind of sync, then guess what? It doesn't matter how good our app is. It doesn't matter what tooling we have around it because it was an oversight that ultimately failed that entire stack. And so again, the key takeaway here is just to think about the bigger picture of these goals. So we're definitely going to have a happy ending for you. We're not going to leave you without pants and not being able to go to work. You were so happy, you were so pumped about this giant swarm seminar that you actually packed some extra gym clothes in your backpack. You were very productive, wide awake, you have your extra clothes. So you're actually able to run behind a tree real fast, you put on your backup pants, and now we have the dependency for everything else, our laptop, our coffee, our backpack, we're ready to go. Thank goodness we had our backup pants, right? So if we take this a step further and we relate this back to Kubernetes one more time, what would be our backup pants in our failed registry scenario that we talked about? Well, it could be a number of things. It could be a local pull-through cache. So let's say it's something that once we pull an image, it's going to cast that image on the cluster. So therefore, if there is a network blip or there is a degradation, we don't feel that, right? Because we can still get our image. We can still get past that single point of failure. We can use fallback registries. So basically just saying, hey, let's implement some health checks, and let's say Docker Hub is down or KeyIO is down. We have a series of health checks if the service is down. Now I want you to use this other registry where we also have the containers. And then I think the last one I can think of that we don't have here is maybe mirrored registries. So if any of you are running something like a Docker Enterprise setup with a Docker Trusted Registry, I believe it is, you can run in high availability, so basically just reaching a quorum, but the same replicas, the same container, the same storage across all three of them. So again, right, just kind of thinking about that whole stack separate from our app, things still depend on it within our Kubernetes stack. So the key takeaways just from this warm up is, first of all, have your goals in mind on how you want to take advantage of Kubernetes. Really, really big, really helpful, even just when creating the roadmap and speccing out the application. The second thing is consider a plan for more than just the code. You know, what are the other tie-ins that you want to build? What kind of pipeline do you want to build? What vendors do you want to use? But essentially looking at all of these options, what can I pick? What can I configure to be the most successful running on Kubernetes? And then the last takeaway from this is iteration and improvement is always going to be necessary. There's never going to be, a moment in our journey in cloud and Kubernetes, probably in tech in general, where we say, hey, I have the perfect setup, nobody touch anything. We're just going to sit here for the next 20 years. I don't think any of us on this call can say we've experienced any tech like it. So just the acknowledgement of there will be iteration, there will be improvement, there will be learning along this journey. Will set you up for a good thing going forward as far as creating these applications. A good place to start and kind of what we'll use as our guideline for the rest of this talk is the 12-factor apps methodology, which a number of you may have heard of. Essentially, just a really nice set of methods that's been around for a number of years on how to write or how to operate microservices. And then the second thing that I'll encourage you guys for is, as we go through this, if you're interested in, let's say, a certain concept or a certain workload, is always utilize your open source examples. More than not, there is going to be a use case already in the community that's going to be covered. More often than not, there's already going to be a blog post of someone who's experienced going through it, their pros, their cons of doing it that way. And we'll talk about this a little bit later as far as don't reinvent the wheel. But just keep it in mind as you're going through that sometimes all you need as an example or a getting started is just a copy and paste from open source and then evolving your business case from there. So we'll kind of walk through some of these guidelines and pitfalls that we alluded to now. So we want to run through all of these right now. We'll go through each one of them as a separate item, but just a high level of what our 12-factor app methodology is actually going to look like, starting with code base and then ending with the admin processes. So the first one is code base, and in my opinion, one of the most important ones, whether designing apps, whether maintaining currently running apps, just really, really huge when it comes to microservices, Kubernetes world. The biggest thing I would say of this is going to be that second point, tracked in version control such as Git. So this is going to be making sure that you have a system to do the correct releases, the correct tagging systems, basically putting them in the areas and marked with the labels that they need to be in a consistent manner, and that consistency being the key word. The reason that we need the one-on-one relationship between the code base and the app is ultimately because of dependencies. But I will give you this example. It's a little separate than, let's say, this next one we have here. So the code base could be broken, and I would say two different ways we can explain it. One of them, we can say we have two example services, example A and example B. They're running independently. However, they're utilizing the same common library of Java objects. What if we actually needed to update that example service A with the common library? Well, what that would look like, because we have these shared objects within the containers themselves, we'd actually have a dependency on that service B as well and need to update both of them. It wouldn't be a huge issue if we have just a handful of services, right? But think about if we're running hundreds or thousands of these services at one time, it would be impossible to track these. And more than likely, right, there's going to be a knowledge gap when it comes to what order it has to happen, what has to do. But in reality, that's not a clean way to do it, right? But I'll switch back here and give you another example specific to the tracked and version control, such as Git. And this, again, kind of a real world example. Luckily, not at our company, but recently talking to a buddy at a different vendor, they actually had a mishap pushing their software. And what they usually do is that within their build process, they were in the bad habit of tagging things with latest. Um, a number of you who work with Docker and have been around the container game know where I'm going with this. But latest is just the default. It's always going to be latest. What they found was they were pushing these software versions into the repo, and these are customer facing, download your patch, put it on your cluster patches. And what was happening is it was taken with latest, and just by chance they were getting lucky, and the latest push would always end up on top. So it was latest, 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 and they didn't know it, but the most recent one was on top. And so they went months and months without realizing this. Well, one day that convention was changed, and then the next day customers were downloading two major patches before a regression, right? So you go and you see the button, update now, a new update available, and you click it. Well, they just backported way back because they had a wrong tagging system. They got the railroads tracked mixed up, basically, right? And so that's just kind of the real value and the immutability aspect of it. So moving on to dependencies, this is a big one, but basically microservices, you have to take that declarative approach to it. The app should never rely on those implicit existence of the system-wide packages. Essentially, kind of what we were saying earlier, it's decoupling those dependencies and keeping it self-contained. So two examples of this I could say is that you just want to fetch at runtime. So one thing that we've seen in the past is, let's say that we have a GPU workload. So something that we want to run, I don't know, video transcoding or something very heavy on and utilize that GPU hardware resource. If our nodes are able to do it and we have our workload, we're still going to need that NVIDIA driver. And so what the preferred approach would be, right, is to go run and fetch that dependency, run that as a separate service, a separate process, and then install it where we need it. The verses of that, and the bad example of that we hit in the past few months, a customer of mine hit, is installing these NVIDIA drivers on the nodes themselves, pushing out their deployment to go on top of it, right? But it's totally logically separated as far as this goes. But what happens the first time that workload lands on a node that we didn't explicitly install that driver? It can't schedule. And so what do we end up with? We ended up with a number of pods needing to scale up, sitting in a pending state until the driver was manually fixed on that node, right? And so that's just kind of why we want to keep these things as is, really in the runtime definition of it. Next up, we have config, and this is storing a config in the environment and not in the code. One really nice way to think about this is basically code should be able to be made open source without compromising your credentials when you're writing it. And that's not to say that you want to open source your proprietary code. That's just to say that you should be in the habit of saying, hey, if Ben or Franz saw my code right now, I wouldn't be opening up a security report with my company, right? Because I know that my config is extracted, my authorization is extracted away from my design. The pitfall, however, though, with the configs, they can get very granular. So if you're managing a number of apps, another of config maps, a number of sets across different environments, there has to be some kind of central management or good way, whether it's a pipeline or that version control that we talked earlier. But there has to be a good way to keep track of the revisions and then keeping things consistent across the environments. So an example of this being broken that we've seen, let's just give a very high level use case. Let's say that we have an application, we need to access an AWS database of some kind, and that was hard coded into the app. If the AWS keys are expired, what do we do now? Well, I mean, easy enough fix, right? We go get new, we refresh the token, we put it into our code, we fix it, we have to build it, we have to run it through our test, we have to push it, we have to roll out the new deployment. So I said easy fix, right? But that just took us half an hour to do, right? If this is a production workload, half an hour is a lot of time just to be sitting there and going, go, 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 right? I hope my workload makes it in time so I don't get another email. But in reality, what can we do to do this? We offload the config. Another example of this, or even in that scenario, we can use KeyM, we can use something to handle that token authentication. But I guess in a more straightforward concept, we can think of core DNS, or one of the core components of these clusters. DNS is something, obviously, it's a little touchy to roll for some people to say, oh, you know, we're rolling our DNS pod, we have to be careful about this. But if you look at a core DNS config, if you actually have the reload plugin in that, there are a number of things that you can change in the config map that will be a soft reload on the pod. So essentially, we don't have to change that core package of our core DNS container because we've abstracted that into our config map utilizing plugins for that. So backing services very simply treat as attached resources. And what I mean by that is we should think of all of these concepts as ephemeral. So the easiest one for our backing services, I would say, would be storage, right? If we're just thinking about state, we're just thinking about actually accessing something in a specific place, we need to try to make that as ephemeral as possible. So calling out to a URL or credentials within the config, basically something that can resolve instead of just pointing, not being there, and then requiring a total build of that code, right? And I hope you see a theme starting to emerge that we're trying to abstract what we need away from these processes and then put the config in a different layer that we can control separately. So it's, again, just decoupling all of these different sides. And as part of this, similar to what we were talking about, the 30 minutes that we were waiting for that production service to upgrade, this is where we could take advantage of that. This is where we see that segmentation. So just separating the build and run stages. Very simply, we can just say it's fetching dependencies, compiling the binaries on the build, and then the run is the actual execution of it, with release in the middle being the tagging that we were talking about earlier. So we know essentially what that is, we know what code that's running, we know what config that is. A pitfall, however, that we've seen is balance between the standardization. So you can have a number of multiple methods that are working within a group, maybe within a team, maybe within an organization. But what really is hard to do is if we're using one method to do something and we're sharing a cluster, another team is using another method to do their builds and releases. And then basically we have this huge knowledge gap now just living on the same cluster. Maybe it's separate from namespace, that's fine, but it's a different deploy mechanism. So people that knowledge transfer across it, and even I would say the community aspect of that, teams helping each other, improving and creating standards is all over the place. So what we typically see in situations like this, leftover deployments, leftover pods, orphaned resources, things that are just kind of left in the wayside because that management level of it, even though they have that process, that management level of it isn't actually, let's say, covering everything. So processes being a huge one for microservices. We talked a little bit about state, but one thing Kubernetes does have trouble with is state. So if you can create these processes as a stateless process, we just always want to think of this as the old cattle versus pet analogy, right? We always want to assume that that job can just be killed at any time and it can be picked back up. So very easy example, if we have a queue, we're going through a transcoding or something like that. If we have a job that was interrupted, maybe the node is just being scaled down due to autoscaler, a normal activity in a Kubernetes cluster, we have to be sure that that state essentially, or that stateless process, we can put that job back in the queue and we can pull it back out. If we're stuck essentially, right, we don't know where we're going to end up, or we might even have to redo that with for long running jobs is definitely a business degradation, in my opinion. So port binding, I won't spend too much time on this one, but port binding essentially just exporting services. And so that just making it easy from the domain level to actually load balance those backend requests. Separate from, let's say I come from the firewall world, if I have a connection on port 3000 and that connection's broken, my app's broken, right? And so we want to see on ingress is we have the ability to actually take via load balancers, via that proxy, actually intelligent routing on the application level to say, hey, this pod isn't ready. I'm not going to actually push anything back there at this point, right? So really just a huge advantage when it comes to exposing your services. So concurrency being able to scale out. Essentially, let's take a web client, will be an easy one. So if we take this web client example that we have right here, we can keep putting muscle and muscle and muscle into a big monolith. However, what's going to be most efficient, whether we get increased traffic load, whether we just need to scale out an anticipated sale, anticipated traffic or something. We want that decoupled service. Maybe it's the HTTP is handled by that simple web process, but then we have separated those jobs out to longer backrun task just in a worker process essentially. Where we can see this go wrong, though, and just kind of a big caveat that we've seen is for scaling and for this concurrency model to work, the Kubernetes, let's say, pods have to be at a certain level optimization. And what I mean by that is in dev, in staging, let's say, totally fine, right? That's what it's for. We're testing it, we're configuring it, we're trying to make it better. But let's give a situation in production. Let's say that we're in production, we have 2 replicas running, it's working fine. All of a sudden we need to scale up to 10, we scale up to 10, and then suddenly our microservices starts to look more like a decoupled monolith, right? That is not a good situation to be in because at that point, scaling really isn't going to help you. That's more of a design thing, that's more of you have to be ready for it. Another scenario that we'll go into typical to this kind of a concurrency model is the monolith example with a longer start time that we'll talk about in just a few minutes. Huge one here, disposability. So like we said, going back to that old cattle versus pet thing again, fast startup and graceful shutdown, I would say are kind of the bread and butter of pods within Kubernetes and within microservices. So we need to have some kind of way to do a graceful handover. I'll give you an extreme example. Let's say that you guys are using a platform or a Kubernetes platform that has a timeout on upgrades. What I mean by that is, hey, we're going to roll X amount of nodes, and at the end of 20 minutes, whether those nodes have finished evicting and draining their pods or not, we're going to forcefully kill those with a sig kill, and we're going to move on to the next batch, which is a practice that we've seen many times on a couple different platforms. What you're facing then is if you have a job that can't hand off what it's doing within, let's say, 20 minutes, we're going to get that sig kill from the actual system. It's going to forcefully kill that process, and we're going to starting it up on the other one. However, if it takes 20 minutes to scale down this process and it takes 20 minutes to scale up the new one, then you essentially have had 40 minutes of a handover that wasn't even successful, right? So if we put that at scale, we really start to see issues when there is a lot of movement, and that being the importance of disposability. Dev prod parity, again, keep environments as similar as possible. I think this is pretty straightforward when it comes down to it, but one thing that I would like to highlight is a real world example of how this kind of both can help you, but as well as hurt you a little bit. So we have a customer most recently within the last few weeks, I would say, I had an issue with Kafka connectors. And these Kafka connectors, essentially, we just saw the max latency just trickling up, right? Just enough on Grafana where you go, is that a problem? So you look at, you just keep going up. You kill the pod, immediately you see this latency start going back. So we look in the environment and we have a full dev cluster, we have a full QA cluster for this application, and then we have our production cluster, which is where the problem's occurring. Looking into this, the only thing that we could find apples to apples that was different is that the node group or the node pool, the worker nodes essentially, in production was running mixed instance types. So they weren't all the same instance type. Dev and QA had the same instance type for all of them. So when we compared this Kafka issue apples to apples, because they were supposed to be similar, we were able to say, oh, this is a mixed instance type. This is probably what the issue is. It was landing on the wrong side of instance types. The flip side of that, though, is we could have caught that before it got to production if we were using a mixed instance type across all of the environments for that app. We would have seen the same issue in dev, and we would have seen the same issue in QA, and therefore we never would have even deployed it into production at that point, right? We would have been troubleshooting at the lower level where that business value, that business uptime isn't as critical. So just kind of something to keep in mind there. And then just coming to our last two, logs being obviously a big one, but from the microservices side of things, I'll just leave it at this. Use a scraper, use something like FluentD to collect those logs and push those logs to something like an S3 bucket or some kind of backend storage. The pitfall, however, that we see within Giant Swarm quite a few times is people want everything logged, right? Which is great in theory. It's a different thing when you go to pay your storage bill and you see how many logs that's actually sending. Super quick, real life example on this. Let's say that we're all working on a team together and Franz goes and he leaves the team. If we want to go and look at any kind of audit logging, what was Franz involved in? Where do we need to pull his keys? And we go to our S3 bucket and we have 6 months of JSON data that has not been filtered. It's useless data to us, right? So unless we have some way to parse it, some kind of tool to make that useful to us, or the other option is just, tune it from the get-go. What do we actually want to collect that's going to be useful for us? It'll save you a lot down the road when you actually need to go and do those look back procedures or even troubleshooting, right? But it really filters out a lot of that spam. And then the last one, just admin processes. So when possible, just running admin and management tasks as a one-off process so we don't have to worry about that. It's just an automated thing that we finished. It's done, all good. Real life example for this one, I like the pitfall, is change it today and forget about it tomorrow. I have to say, one example of this really, really big cluster that we've had recently, it was hitting a component, essentially cluster autoscaler, was going just because of the size of the cluster. Pretty easy fix for us, right? We go in and we up the memory requests, we up the memory limits. It auto rolls out, everything's happy, it's running. Good, good job, everyone, right? Pack it up, go home, we fixed the issue. Well, we did until that change was reverted due to an upgrade, right? Because we didn't roll this up with a one-off test. We didn't roll this up into a release. It was a manual thing that wasn't done in any kind of official process. And because of that, we made the change, it fixed the issue, but we never actually went and permanently fixed the issue. And it bit us a few weeks later when we had to fix that same thing and then go, hey guys, let's actually put it at the top level, the global level this time, right? Let's include it in next time. So now we'll get into just two pretty quick scenarios here, just going off the guidelines that we talked about earlier. On the one side, the guidelines of the 12-factor methodology, how should we have our goals? How should we aim to do things? And then the flip side of that is what happens if we don't do it, right? And so we'll look at a few bigger, just two here, scenarios that we can kind of walk through. So the first one, a common one that everyone sees from the microservices world, is just kind of the lift and shift mentality. Maybe you're redoing all of your applications from ground up. I would say I don't see that a ton. Even companies who are going all in on Kubernetes still usually have these little trailing services, right, that we kind of have to limp in or figure out something to do with. So the lift and shift mentality, typically I say just, get it out of your head to start with. It's something that isn't really going to be successful. Forcing applications into Kubernetes that aren't designed for it is ultimately just going to be more work, in my opinion, than refactoring it or redesigning it from the get-go. The reason being is the second point, and I think this is a really big key, especially for Kubernetes. Running a pod successfully or running a deployment successfully is not the same as production ready. And we'll take a look here at maybe why that is. And so we'll just do a quick example here of our team has tasked us with porting a big monolith Python application. We've teamed up, we've wrapped it in a container, we have our big Ubuntu base image, everything's working, we're really happy with it, and we push it to our Kubernetes environments. It's running, it's green, everything works like it's supposed to. The issue is because of the monolith and all the dependency checks initially, the container has a 20-minute start time per pod. And for anyone thinking that's a huge time, that would never be the case. Not true. I can think of probably 5 to 10 customer services currently that are in this scenario where, hey, we want to optimize it, we want to do it down the road, but it's not there yet, right? So let's say we have a 20-minute start time per pod. All of a sudden you get the pager. You get the pager and you're going, hey, what's going on? Well, there was a security flaw that was found. And now, instead of just making this change, rolling up our release, let's say, and then pushing it, well, what we saw is that the 5 replicas now take us 100 minutes if we're rolling one by one instead of 2. So 100 minutes instead of 2. Think about in a sub-zero situation, think about in a P0 situation, what that opportunity cost and what that business value is actually going to be. So going back to our first thing that we were talking about, just the portability, the speed, the agility to be able to make these changes. Yeah, absolutely. So around 10 minutes, yeah, definitely. And it's something that, it's hard to get around, right? And it puts a lot of effort. It does. It takes a lot of work to decouple it and to decouple it in a way that's not just being deployed as a bunch of services that still depend on each other, right? And so I think this is very, relevant to that. And I've definitely been guilty of this, right? You can see my second line, Ben, what'd you push? I mean, it was only an if statement. It shouldn't have broken anything, right? Now you're at the beginning again, reverting it, pushing it back out, and just look at how much, a little mistake like an if statement. Again, true story has happened. It was only an if statement. We were on a P1 call for this rollout, essentially. Another way that something like this can break, having a harsh, wrapping a monolith. Does your team control the upgrades of the cluster? For some of you, that might be yes, absolutely. So you can dictate when you want to do that. You can put up special considerations from that. From the majority of customers that I've seen in the past, It's not the case. And why that can be an issue, let's say we're going home, we're all hanging out with our family having dinner, and then you get the text or the Slack message, hey, we're upgrading your cluster tonight at 8 p.m. Uh-oh. Right? Our start time's too big. We have 3 replicas running. So as soon as those 2 replicas go, we're going to have, let's say, 10 minutes or let's say 20 minutes of this startup time that we're just waiting. We're just waiting for that to happen. So that can potentially bite us if we just don't have control over the upgrades or control over the node movement. Maybe it's even a cert renewal that we do, right? Just rolling these, or even let's say a chaos script, which we'll talk about in one of our last slides. And then the last way is, let's say this service has to scale up based on traffic demand. So what if we had a huge sale that started 1 minute to another minute, huge traffic spike, right? If we have a 10-minute startup time, even if we have our scaling configured, even if we're ready to go, we still have to wait for this to actually scale up, to actually start, for that readiness probe to finish, and for Kubernetes to say, hey, now I can start sending you traffic. You're ready to start serving traffic. And so what that ends up looking like is we end up looking like this lady right here, just hoping, right, for a matter of few minutes. You see the big spike from Akamai, from CloudFront, of all the traffic coming in, and you're just going, man, I hope that starts up soon, right? Weight of the world on your shoulders. And how would we fix this? Well, from a high level, you go all in on Kubernetes, like we were talking about earlier. So that being everything around it, the tooling, the monitoring, the troubleshooting tools within it, whether it's a debug, everything like that. And then finally, utilize the 12-factor methods that we talked about, having in mind both our best practice scenario and having in mind our also pitfall scenario, or how we can misconfigure this and get in a bad spot as well. So the second and last scenario we have is don't reinvent the wheel. It's something, Giant Swarm especially, we're really, really big on open source. Reason being because the power is in the community to cover these use cases, to work together in doing this. And so far, it's been very, very successful in doing so. So my point being, Kubernetes doesn't make things easier at first. It's not a shortcut to put something in and say, hey, I'm in the cloud. Kubernetes is something that there's a huge upside, there's a huge chance to take advantage of the platform and what it offers you, but it does require the tooling, it does require your own learning, your own training, and it does require just some different considerations as far as thought process when we're going through. And again, thinking, running is different than production. So maybe I have a running container now, but what would I want to build up around it in order to be very confident, whether it scales, whether there's an upgrade, whether there's a traffic blip, that it's going to handle itself, both from an ephemeral nature and an autonomous nature. So let's say that we have an application not designed for Kubernetes. This is a legacy build pipeline app deployed as a static pod. And I'm just going to say, this is a typical old Jenkins deployment that we see. When people come, I know a lot of people like Jenkins, but I would say this is a typical Jenkins legacy deployment that hasn't been redone or anything. It's deployed as a static pod, and we have this server that lives. And when we push out a build, it's going to spawn a bunch of these client pods, and each one of these client pods are going to do a check-in to our server. Okay, so that's just kind of the basic thing. We go through, we do a few builds, we see our pod spawn, everything connects back to the server, and we're awesome. We're rocking and rolling. We're like, this guy, we think we're the greatest engineer ever. Cool. We have a build line pod. Well, we went home and the pager's beeping again. Why is the pager beeping again? We just tested it. It looked okay. Well, there's an upstream network blip. Again, something totally out of our control. Maybe it's in Azure, maybe it's in AWS, maybe it's your on-prem, but there's a network blip. That's something that happens, absolutely happens. There's no restart controller for that failed pod because we're running as a static pod. And we don't have any kind of back off controller. We don't have any kind of monitoring around it. So the only reason we even knew this failed is because the developer who pushed it didn't see this update and said, wait a minute, so how do we fix it? Well, via Kubernetes, we can't really do anything. We actually have to go back to the build and kick off the entire thing again, which obviously is not optimal there. So fixing the app in this case specifically, We can use app-specific health endpoints, again, building up our supporting within the container itself. So app-specific health endpoints telling us when it's actually ready to try that echo, when it's actually trying to serve that connection. Readiness and liveliness probes, again, readiness just being when it's ready to actually handle incoming traffic. Liveliness probe when the container is actually in a running state. And then finally, the correct update termination policies. So just, do you want to roll out one at a time? Do you want to put your pod disruption budget in place to make sure a certain amount are up at all times? But basically just the tooling, the config, the objects around it. I won't spend too much time on this, but I just wanted to demonstrate these are all liveliness probes that you could implement all different ways to do it. Point being, like we were talking about, there's a lot of really good ways to do stuff in Kubernetes. So look at your business use case, look at what makes sense to do it for your application, and then you can pick. So as you can see here, if we needed a command to check something from a shell, we can just enter the command we need. If we wanted to hit an actual HTTP response, we could use an HTTP response. The last thing, we could just do a simple socket check if we wanted to do that. And then a quick example of a misconfig, I just thought this was an interesting one. So basically, this is one that you can see here. I always thought, and this was a real customer issue that we looked into, that essentially in this container, you say they have this simple argument. So for app in, look at the app name, look for our jar file, start the app, and then be done. Pretty simple. Well, we got hit up from the team saying, hey, something's broken. It's in a crash loop backoff, as you guys can see here. It's in the crash loop backoff. It's restarted 10 times. I don't know what's wrong with it. Well, you can see the kicker here is the exit code is actually 0, meaning the command is running just fine. It's a misconfig of the container. There's not actually anything wrong with it. So it's doing this job, it's starting the app, it's exiting, and then Kubernetes, because this was misconfigured, is actually restarting it to do it all over again. So from the Kubernetes perspective, crash back, loop back off, hey, something wrong with my app. In reality, no, it's just a misconfig of some simple probes that can be fixed very, very easily. And then the last thing I'll mention as far as improvement goes is utilizing and contributing to open source. I touched on it a little bit earlier, but really picking apps and designing apps for the Kubernetes and cloud native approach will make things a lot easier for you moving forward, just because it is designed for that, because those use cases are available, and because you have the community behind you to reach out to people and get those firsthand experiences, whether it's the partners, whether it's just people on Slack, GitHub, etc. An example of that is Cluster API. If you guys are familiar with Cluster API, giant swarm right now, we're all in on Cluster API. It's standard controller essentially from upstream that you can be able to port, let's say from AWS, from your Azure. VMware is also working on an on-premise version of CAPI. So just really, really cool, but essentially this, right? If we contribute to Cluster API, if we learn Cluster API, if we build around Cluster API, we can port to other platforms, we can talk with other companies. We don't even need to be on specific clusters, right? So really just take advantage of open source not being a lock-in, not being proprietary, and then essentially not having to maintain some proprietary code that you have. And then just the last 2 slides we have before we open it up is just some testing tips. So one of our CTO's favorite lines that I have fully embraced is, if it hurts, do it more. And what does that actually mean? Well, if you guys are having trouble doing upgrades, if you're having trouble with these deployments, if you're having trouble with these stress tests, simply do them more. Obviously in a controlled setting, so that being dev, that being QA, but where you really improve your applications is when you really try to break them. And that being the whole premise of what we're trying to get at here. You have your goal of your best case, what am I taking advantage of in Kubernetes? But then we also have the other side of it. What can I do to go in there and ensure that in any scenario, things are going to be okay? So for upgrades, you're going to learn which services struggle. You're going to learn where you need maybe support around tooling, around monitoring, etc. as you do this and as you try it and as you experience it. The other part of this is going to be chaos engineering. And I won't go too much into this, but chaos engineering simply being go and break your stuff on purpose, right? You can write scripts for this. You can go in and manually do it. But I would just sum it up like this. Most of us have probably been in some kind of technical interview where you have the technical interview. They say, hey, troubleshoot this connection. and then all of a sudden, hey, we just killed this port, right? Chaos engineering. See where things break. How do you get around it? And it's kind of fun doing it most of the time. And then lastly, just learning will always be a constant. So just consider everything part of the stacks. And finally, guys, it is worth it. It's totally fun. We've all been doing it for a few years here at Giant Swarm. It's super fun. The community is great. And in the end, you will get that value exponentially out of your workload. It will be easier for you, and you will have learned a lot. And that's it, guys. So thanks for listening to my thoughts, and feel free to take down my email as well if you ever want to reach out and chat, ask questions, opinions, or anything like that.
Really awesome. Thanks so much, Ben. And actually, I can really relate to the point, just like of the chaos engineering. I just spoke to a customer this afternoon for 1.5 hours, and we actually, in the last future perspective, we actually talked about how, how disaster recovery is so important. And he said, yeah, he wants to be the guy who pulls the plug and see what happens.
Yeah, exactly. It's a really cool concept. Like, even I'd be interested too in what some of our members think here is the concept that we're kind of trying to push on the chaos engineering line is, what if you said, hey, every Tuesday at 8 a.m., right, we're rolling our clusters. Exactly. They're going down, and it becomes a habit instead of a worst case scenario, right? Yeah. And that's pretty cool stance to take, I think.
Yeah, it is, and it actually works very nicely because it, you can really test it in a, in a safe environment. But you can actually also, as a platform team, you actually don't have that much, impact on the development teams. But like once you roll the clusters and the pods, and then suddenly the application just like doesn't come up again, it's something that actually gives you feedback as a development team. So, oh, gee, like, something's wrong here. It's like, that could happen in production anytime. Yeah.
Absolutely.
So cool. Yeah. So guys, if you actually have questions, you're already getting great feedback. So that's really awesome. If you've got questions, just ask them. And also, with your registration, you also have access to all other webinars that we have posted also on giantswarm.io webinars. So you can just go off and visit that. Also, very happy if you guys have any suggestions, what you actually would like to learn about. Here, Sabari actually would like to hear about service mesh. Actually, I think there is already a presentation around that, but we actually can definitely prepare one for service mesh. There's a lot of discussion going around with Istio and Linkerd and so on and so forth. It'll actually be interesting, especially Savari, if you actually have a special use case in mind, because there are people that want it for security reasons and other for logging and so on and so forth. So really figuring out these these different use cases and whether service mesh makes sense at all or not. But actually, while we're waiting for questions to come in, I don't know if there are some more, but I found your presentation really great and insightful. And I was wondering, it's like, you've got these recommendations, the factor, 12 factor. So, how do you make sure it happens? Because all the examples you actually gave of companies that kind of failed to follow these recommendations, or companies that have done this for years, they're really pros in this area. So it's actually really difficult to always think of these things. It's like, do you have any recommendations on how you actually can make sure that it happens? Or
Sure. So, I think one thing actually, and that's a good question. One of the things for me that I recently learned about this concept at Giant Swarm actually is that was the part, let's say, about the standardization of that build release step. Mm-hmm. If we across the company or across application teams, let's say we have a standard, whether it's tool set, okay, maybe debatable, but definitely when it comes to the process of documenting the code, deploying the code, and releasing the code, so putting our tags, our labels on it, right? If we can get to a standard place of that, to where maybe Franz, you and I are on different application teams, but I can look at your deployment and I can say, oh yeah, if I needed to, right, I could push out their application, or I could read their documentation. I could see how they did it and the steps they walked through. But essentially, if we can just get that same thought process across, so in Giant Swarm, I'll give you guys the example. We have an Azure team, we have a AWS team, we have our apps teams, all separate teams when it comes to the development and the building cycles of it. But because we have the same build process, because we have the same, let's say, repos when it comes to using Git, the same places that we're pushing things to when it comes to the registries, every one of these teams can say, oh, this is where this is going, or this is how they did it. It's not a secret, let's say, how the code got to where it is. And I think that insight a lot of times really just gets everyone in the mindset of, hey, this is the common goal of building up these apps from the ground, because you have that standard that you're aiming for.
Yeah, no, that's so the standardization, like more the structural, process definition and implementation is kind of what you're talking about, right?
Yeah,
That's what
absolutely.
can help. And what about like there are some parts that are more like infrastructure driven, platform driven, and others that are development driven. So like kind of the standardization is like the DevOps team having a CI/CD pipeline deployed across the all teams and so on. Like how who takes part of what like side of the responsibility and like how do they actually kind of make sure that they take care of their respective parts?
Yeah, I think that's a super great question. So I think, the honest answers for different teams, this is going to vary, but I'll give you, I guess, kind of my opinion of what I've seen work the best. And what I see work the best typically is the, own your pager, own your pain, essentially, right? So I, as an application developer, I'm creating one, I'm pushing it out. If my deployment, since I've just pushed this out, let's say, is in a crash loop, I should be the one, right, looking at that, looking into the code and saying, hey, what changed between my deployment and my new deployment? But kind of tying in the standardization, where what we were talking about that just now, if we have the standardization, someone like a DevOps team or an infrastructure team can take a look at that application and have a reasonable amount of effort, right? Is this going to be on the infra side? Is this going to be on that logging side? So I would say it's really the tooling around it, I think, is what gives people insight to it. But if you can lessen the knowledge gap between the DevOps side and the application side, I don't think it becomes as much of a it's your problem versus my problem.
Exactly.
Yeah.
Get them more time together and really
Absolutely.
have more a DevOps guy in the team, so they can actually then basically develop this better understanding and collaboration.
Absolutely. Yeah.